Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at the nature of the roots. Okay, the nature of the roots. So, nature of the roots is basically a nature of the x-intercepts. Ne? When you think of the roots, you must be thinking of the x-intercepts. X-intercepts of the parabola, basically, right? So roots basically refers to the x-intercepts. Okay, perfect. And then remember, when we do the x-intercepts, we use a what? A quadratic formula, right? This is your quadratic formula that you use for the x-intercept. But on the quadratic formula, we have a root here. Let's see. Let me get my highlighter. Let's see. We have a quadratic form. We have a root here. You see the square root. Ne? This value inside the square root is the one that is going to determine the nature of this square root. So basically, this is the most important part that we're going to need when we do the nature of the root, because it's the one that is part of the square root. Ne? So it is the one that is going to tell us the nature of this entire root, because it is the one that is inside the square root. I'm sure that makes sense. Okay, perfect. So this number inside the square root, we call it a discriminant. Ne? We call it the discriminant. And is represented by delta. Ne? It's represented by delta, which is b squared minus 4ac. b squared minus 4ac is the most important part of the nature of the root. Make it your best friend. We're always going to use it when we do nature of the roots. Okay, awesome. Let's change the pen color back to normal. Okay, awesome. So now I want us to talk about the delta, right? Firstly, we know that the discriminant, right, which is b. So I'll just use discriminant, but you need to remember that discriminant, I'm basically talking about b squared minus 4ac. Ne? Okay, these are the cases of the nature of the roots. The first case, if the discriminant is less than 0. Less than 0 meaning negative, right? If it's less than 0, our roots are going to be imaginary. Ne? Imaginary roots. So what I mean is, if you have a negative number inside the square root, your roots are non-real. Sometimes they will use what? Non-real. Ne? Sometimes we use non-real, because we cannot have a square root of a negative number. Okay, perfect. And then I just want to show you how this is related to the parabola. Ne? Perfect. So if your roots are imaginary or your delta is negative, ne? This is how your parabola is going to be looking. I'll just do a rough sketch there. If this is your x-axis, right? If this is your x-axis, your parabola is either going to be doing this or doing that. Does make sense? It's not going to be touching the x-axis. That's what it means when we say imaginary roots. We mean the x-intercepts do not exist. Okay, perfect. Now, let's do the second case. Ne? The second case is this. If delta is greater than or equals to 0. So by greater than, we mean it's positive or it's 0. Ne? Our roots are going to be real. Ne? Real. So we're going to have real roots. So which means by real roots, we mean we're going to be touching the x-axis. Remember, roots are x-intercepts. I'm going to repeat this and over again so that it makes more sense to you. Okay, so in this case, our roots are going to be real. Why? Because we're going to have a positive number or 0 inside the square root, which is going to give us an answer when we press it on a calculator. Okay, perfect. But the real roots are subdivided into further categories. Okay, perfect. I'm going to try to move as slow as possible so that they make sense. So I'm going to call this number 3. So let's say we had delta being equals to 0. Ne? If delta is equals to 0, which is part of this, I'm trying to break this down. You are going to have real. So your roots are still real, and then they are equal. And then they are going to be rational. Ne? Rational roots. Okay. Why am I saying real? Because the number is 0. Remember, for real, we need 0 or positive. Why am I saying equal? It's because here, if you come here, you are going to be adding a 0 and subtracting a 0. So adding a 0 and subtracting a 0 will give you the same answer on the quadratic formula. So that's why they are equal. It's rational because 0 is a perfect square, right? Remember, 0 times 0 is 0. So 0 is a perfect square. So your roots are rational. Ne? And then I'm going to show you how this one looks on your parabola. Okay. So this is how it's going to be looking on the parabola. So your graph is either going to be, if it's facing up, going this way. So it only touches the x-axis once. Ne? If it's going down, it's going to be doing this basically. Okay. Perfect. Then yeah, that is for when the discriminant is 0. It means your parabola is touching the graph only once. Ladies and gents, please always be thinking about the parabola when you do the nature of the roots, because nature of the roots tells you how the parabola touches the x-axis. Okay, perfect. So now we're going to do number 3. I mean number 4. Ne? If delta is not equals to 0, but it's positive. If you check, 2 is further broken down into this and that. Ne? Perfect. So this one is positive, so we have a positive number under the square root, so we have real, right? And then our roots, since we are going to be adding and subtracting by a number that is not 0, our answers are going to be different. So we're going to have unequal, and then here is either going to be irrational, or rational. Ne? I'll explain how to see the difference. Irrational or rational roots. Okay. And then obviously here we have the roots are going to be how many? We're going to have 2 roots here. Ne? So on the parabola, your graph is going to be looking like this. If it's facing up, it's going to be like that. If it's facing down, it's going to be like this. So it's cutting twice because the roots are unequal now. So they have to be at 2 different positions. Ne? Sharp. Now let's talk about rational and irrationality, ne, of the roots. Okay. Sharp. So if the roots, for the roots to be rational, right? The number that you are going to be having here under the square root must be a perfect square. By perfect square, I mean 0, 1, because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on and so on. Ne? So we need to have what? A perfect square for the roots to be rational. And then here we're going to have a what? A non-perfect square. If a number is an unperfect square, then your roots are going to be irrational. For example, if you have 2, you have 3, you have 5, 6, 7, 8, 10, 11, and so on. Your roots are going to be irrational, right? And that's the theory that you need to know about the nature of the roots. In our next lesson, we're going to be doing activities on nature of the roots. Please follow the lessons and make sure you leave a comment and share with family and friends. I hope this was helpful and tune in for lesson 2. Thank you very much. Have a great evening. Danko.